Okay, so this is 6.3 part, 6.3? Yeah, 6.3 part 2. So we're working with bacteria here. The number of bacteria in a Petri dish on the first day is 2. So it starts at 2. First day is 2. And the number doubles every day. The variables in this situation are the number of bacteria, measured in number, and time measured in days. So who's in charge of who here? Good. The time is in charge, so it's the independent variable and also the input. The number of bacteria depends on how much time, so it's dependent because it depends on somebody, dependent, and also the output. So for this one, we'll just make an arrow. We already answered it. So we have to create an input-output table. So my independent, we said, was time and days. And my output was number of bacteria. So let's see. The input, so on day 1, it said there were 2. It says that number doubles, that number, the number of bacteria, doubles each day. So on day 2, it's 4. Day 3, it's 8. Day 4, we've got 16. Day 5, we've got 32. Day 6, we've got 64. Day 7, we've got 64 times 2 is 128. And 8 gives me 128 doubled is 256. Okay, so before we start the process, let's graph it and see what it looks like. So the independent down here is days, and this is number of bacteria. So days we can go by ones because it's 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Number of bacteria goes all the way up to 256. Ugh. So we've got to jump pretty much a lot. So let's go by, maybe 20s would work. 20, 40, 60, 80, 100. 120, 140, 160, 180, 200. 220, 240, 260, and that's enough. 280 will go. All right, so let's see what this graph looks like. At day 1, I'm at 2, so it's like barely above the line. Day 2, I'm at 4. Well, that's like barely above that because that line means 20. So we're getting pretty small here. So we're up a little tiny bit. Day 3 is 8, so day 3 goes a little bit higher than that one, but not much. Day 4 is 16, which is closer to the 20. Day 5 is 32. Well, 30 is in the middle, so go tiny, tiny, tiny bit above 30. Day 6 is 64, so we're going to jump all the way to 60 and a tiny bit more to 64. Day 7 is 128, so jump all the way up to 100. There's 120. 128 is like almost halfway. 8 is 256. Holy cow, so we've got to go all the way up to, let's see, there's 200, 220, 240. 260 is too much, so 256 is probably right there. Can I have a half a day? Well, sure. So look at the shape of my graph. It's almost like half a U, isn't it? Like a half a U. When you see this shape, a half a U, you know you're dealing with squares. You know that your input, is dealing with squares. So here's what we have to do. We know that whatever it is, we're going to put in this 3, we're putting in the 4, we're putting in the 5, we're putting in the 6, putting in the 7, putting in the 8. We've got to figure out something to add or subtract to get over here. So let's see. We've got 1 squared is 1, so we'd have to add 1. 2 squared is 4. Oh, so we wouldn't have to add 1 there. Let's see. We've got 3 squared is 9. We'd have to subtract 1. 4 squared is 16. 5 squared is 25, but then we'd have to add something else. So if this doesn't work, remember that not all functions have a rule. So this one doesn't have a rule. For now, we'll figure it out later. But for now, we're going to pretend like this one doesn't have a rule. Okay? So here's what happens. So what we need to do is determine if this truly is a function with the vertical line test. So the vertical line test, we're just going to drop a vertical line straight down. Each vertical line only hits our graph once. So yes, it is a function. Hang on 1 second. Hi. We're recording, so quick.
I know. No, I just wanted to watch what you're doing.
Okay. All right, I've got an audience now. All right, so here we go. Define the variables and write a function rule to describe the relationship between the number of bacteria and the number of days. We're going to actually skip this one because what happens is it's called exponential and we're not there yet. So it's okay to skip this one. Just write Ms.O said so. All right, so we can skip both of those. All right, where are we? We've only got 1 more to go, so let's squeeze this in real quick. Now that you have some understanding of independent and dependent variables, complete this math journal entry. So get ready to write, stretch out those wrists. You may look back in your book and notes, so you can look back, but be sure to state the idea in your own words, not mine, your own words, and provide your own examples. So if you haven't been able to come with this on your own, use mine, but switch it into your own words. So independent variable to me means input. It also means the x. It also means the variable in charge. An example of this would be, let's see, we just did one. So the number of tables is in charge of the number of people that can sit down. So number of tables I'm going to square off or circle because that's the independent variable. All right, guys, 1 more. We're almost done. All right, dependent variable is the output. I also know it as the y. I also know it as the follower. And I also know that it's the one that gets told what to do. Gets told what to do. So this same thing, is in charge of. The number of people is the dependent variable. All right, guys, keep working on that. I think you can handle staying sharp. Let me look. Rule, rule, rule. You can do that one. You can do that one. I think you got it. You can go ahead and skip. Actually, no, I want you to go ahead and try that one. Your minimum x value is the smallest value in the table. Your maximum x value is your biggest value. And then you can find what's wrong. You're good. I'll see you guys in class.